Hi, everyone. My name's Chase Williams. I'm the CEO and a co-founder here at Campus. I am joined by Chris Hagan, our Chief Technical Officer, and one of the masterminds, along with his brother, behind a platform we're going to talk about today, which is called Flow. I'm also joined by Christine Dumont from Salve Regina University, as you can see on the screen. And Christine's going to take us through what they're looking at from an integrations perspective at Salve at the moment, and how they might be considering utilizing a platform, a middleware platform like Flow. For those of you who don't or haven't heard about Flow or know what Flow is, Flow is actually in production at many, if not all, of our partner institutions. It's the platform that we've built in-house in order to do deep integrations and map data from your systems into Campus for the purposes of things like user provisioning, for notifications, for widgets, and things of that nature. But Flow can be used independent and outside of integrations with Campus. It's its own middleware platform. So we'll dig into that a little bit today, but I want to throw it over to Christine to introduce what Salve is looking at and their specific use case before we dig into Flow.
Okay, well, thank you very much, Chase, for this opportunity. My name is Christine Dumont. I am the Senior Director of Enterprise Applications here at Salve Regina University. I get asked a lot, what does Salve Regina mean? So it's Latin actually for Hail Holy Queen. We are a Catholic coeducational university founded in 1947. And we are located on the Cliff Walk here in Newport, Rhode Island on the beautiful Atlantic Ocean. We have just a little bit under 3,000 both undergrad and graduate students this past semester, and about 400 full-time faculty and staff. Now, about a year ago, I'd say, we were in the market for a new portal. So we started investigating our different options and we came across Campus. It was very impressive, the nice modern feel, the amount of integration, especially the integration in mobile devices that we really liked. So we went live with Campus in July after purchasing it in May. And during the implementation, as Chase had mentioned, we used this product called Flow. So Flow was able to take data from our Canvas LMS system and present it as a widget for our course information for faculty and students. It also took data from our colleague. We are an Ellucian client, so we use Colleague for our student information system. It took our demographic data as well as notification data, and we use that in order to personalize and get students and staff into specific groups that made sense to them. So it's something that was running in the background and really allowed us to have more flexibility within our portal tool. So recently, we finally finished our migration to the Campus portal. That was in January. And so now we're on to our next project, which is this concept of an enterprise data warehouse. So the cornerstone of our enterprise data warehouse is going to be our graduate studies data. And so we have two separate sources of truth right now. We have our colleague data, which is our enrollment, and then we also have our Slate CRM data for admissions. So we are going to be tasked with bringing both these disparate data systems together and then displaying that in a strategic report. So this particular project just kicked off in January, and we have about a little more than a year to get that completed. So when you look at the current state of all our data systems, even though we're just starting with those two, the goal of our enterprise data warehouse really is to expand and to be able to pull nuggets of data from different areas across campus so that we can have better, more robust strategic reports. And when you look at our landscape of all the different systems, it resembles a spider web. And I'm sure I'm not alone, you know, if you were to map out all the different applications that are best of breed that you've accumulated over the years. So we have some that are in the cloud, some that are on-prem, and right now a various number of methods that we use to take data from one place to another. Some is batch, some thankfully is TCP/IP, and others are just plain manual. Even if you just focused in on looking at our graduate studies data, just that piece of the cornerstone that we're going to start first for the data warehouse, we have this transformation that comes from our Slate CRM, moves into our colleague database, then out to another data store, then we run a report, then that report gets transformed again and manipulated through pivot tables until it's finally displayed in Tableau. And I bet everybody's thinking the same thing. That's incredibly inefficient. And so we recognize that as well. So what we want to do is have something that's well more streamlined so that we can take, say, all of the possible systems of record, whether that be our colleague student information system, our CRM, or Canvas, any sort of data that could exist in any of those, that spider web. And then bring it into a staging area where, again, if we needed to transform it or use any sorts of logic against it, before it gets loaded into a nice, clean enterprise data warehouse that would then be reliable for business intelligence and analytic reporting. So what ended up happening was, as we were looking at this project and we're thinking to ourselves, well, what sort of tools do we need in order to be able to take this data, for one, and stage it, and then second, actually transport that data and maybe make some changes to it along the way. So what we really are talking about is something called a messaging middleware. And that's where I'm going to pass it off to Chase, because actually Flow is a type of messaging middleware. So that's kind of our story up until now.
Thanks, Christine. And does anyone, we'll take a look in the chat, based on what Christine went through, does anyone have any questions before we jump across to Flow? It was all very clear, so probably not any questions. Okay. Let me share screen. Everyone see that? Okay, so I'll be screen sharing, but I'm going to let you take it away, Chris.
Thank you. Thank you, Christine. I simply can't do a better job of illuminating our partners' problems and the problem the domain exhibits all over the place. Marvelous work. So Flow is a classical middleware, among many other things. And what a classical middleware means is that it sits somewhere in the center of a number of interacting applications. And it has the responsibility of making it so that these two systems aren't so strongly aware of each other's exact configuration and needs, so that every time this one changes slightly, this one has to get pulled along. And manifestation of that pattern might be that you are down in an LMS or a colleague or a database, and you're writing reports which are precisely tailored to the expected format of consumption over on this system over here. So when your marketing team has a great idea and they go, we've adopted this cloud system over here, you go, that means that we need to change all of this stuff down here. You've suddenly given us this work of adapting to this problem over here, and we're not even sure whether this one is going to be able to interact to that. Maybe this system over here wants to be spoken to on APIs, but this system over here only has the ability to emit a CSV over email to a chosen person inside your institution. The technology and tertiary space isn't as forward thinking as many of our academics and all of our students are every time. So what a middleware does is it sits in between, it's in the name, and it says, I will take responsibility for obtaining data from over there and bringing it into a central space, sometimes in a very transient sense, and sometimes in a quite permanent sense where it caches it and retains it. And then when these systems out here change their needs or exactly how you have to talk to them or what format you have to use, that all happens here without impacting on those source systems. And they become what we technically call decoupled from each other. When you have a spider web, good word, Christine, of dozens and dozens of enterprise applications, the permutations of change mean that essentially your entire ecosystem as a whole is always in flux. Something is always in upgrade at any moment. Something is being sunsetted. Sometimes it's because there's a good new business capability that's coming online. Sometimes it's because a vendor is doing a process improvement on their end and they are forcing what they describe as a superior model down to you. And we've all sat a little helpless as these sorts of things happen to us. Middleware is a way to insulate ourselves from this natural ecosystem change that is occurring at all times. We may move on slides, I think, Chase. Thank you. So what we've just described is Christine's spider web and all of these permutations moving around and the net effect that at all times you're in flux. Next, please. When you bring in a middleware, you start to see that each system is only able to impact its relationship to the middleware, and the middleware prevents that system from touching on to all of the other places directly. As long as the middleware understands that you've got a new protocol of communication with a source system, or that a system has changed locations or modes or features, it's able to turn to the other systems which are consuming the data and say, I haven't changed anything for you. Something new came online and a new piece of the world came along, but it wasn't relevant to you, so I haven't changed your protocol at all. Nothing has changed. And that might be that it is continuing to call APIs. It might be that it is continuing to emit an output report. It might be writing directly into a database. Next slide, please. I should mention, by the way, that for every rule, there are exceptions. There are protocols of integration such as LTI, which mean that two systems are natively very closely coupled together at a presentation and a view layer. There are systems such as OAuth protected systems where the user is actually going to make a call from the browser to bring data in, and there won't be a system in the way. So your Microsoft calendars, your Google documents, your Canvas or Moodle or Blackboard may very well be doing an LTI integration, and you may have OAuth in play. A conventional middleware has no relationship to these sorts of things. It just says, if you're going to have people directly touch each other, I don't know what to do with that. But there are still problems to be solved in that sort of domain. Many people use a portal to perform a function like network gating, which is to say, I only want students to be able to get to that system if they're on campus. Well, what does on campus mean, especially after 2020? What they mean now is, I only want students to be able to touch into that system if they have verified access to this earlier system. I want the portal to stand in the way. A portal? That's probably Latin. I'll ask Christine afterwards. And protect the access through to these systems in the back end. We used to be able to say you're physically going to be connecting to the routers on campus, but we can't say that anymore. And so the portal often finds itself occupying a position of standing in the way of other systems. Sometimes it finds itself in the position of mediating the manner in which authentication takes place back to those other systems. And although Campus is not an identity provider and Flow is not an identity provider, we have several contexts in which we perform an identity mediation function, which is to say that login occurs and it no longer occurs to that system back there, it occurs directly to Flow. And Flow actually enriches that payload and adds things about the user before the system back there gets them. And what that gives you is a vastly more efficient pattern where rather than two systems that are back behind the wall having to exchange database information with each other, sometimes now it can just be done on demand. And we're treating the fact of authentication as if it were just another integration step to be enriched and to be enhanced. In this manner, Flow is an application server, and it serves the function of standing as a web listener. It enables requests to be served. It enables resources to be loaded onto it. And Flow actually sits in a position in your ecosystem, which is all the way from, I have helped data move around in the back end, to I have made it so that APIs can be called from one system to another without needing to exchange my precious application credentials. All the way through, I have had a role in protecting network access from on-prem to the cloud and back again. And sometimes even all the way out to, we are serving up widgets, which are hosted on Flow and ensure that the user has an authenticated session, down to the back-end services that run against those widgets, back to the work to connect data into those services, into those widgets. And back here, Flow is safeguarding your precious database credentials, your precious API keys, and the trusted access that it has back to systems such as the web inside Salve. Let's move forward a little. Next slide, please, Chase. Thank you. Now, this world that we're describing is a vastly complex one. It's not just that there's a spider web of applications and systems which are going to move to each other all the time, but there's also a legacy of use. Academics and academic administrators are some of the most ingenious people on the planet. If you give them a job to do and you give them half of a tool, when you come back next week, you'll find that they've built themselves the rest of the tool and they've done all sorts of creative and clever things to get the work done for their students and for their team. But it's not necessarily going to be done in the same way as every other system user would have done it out at other institutions. Endemic to our industry are things like magical string codes that float around inside our data. And the first 4 digits indicate what the month and teaching period is. And the next 3 indicate the mode of teaching. And the next 5 indicate some particular cohorting factor. Because the users who constructed the use of this system, they had a string field to work with and they had 4 things to say. So they built a special compound piece of data and they passed it around and they all knew, because they were in the secret society, how to deal with that string when it came through. But it was opaque to the systems that were handling it and that were trafficking it. It was a human interpretation problem. In computing, we know that human interpretation problems are usually the most fallible part of a processing system. But we also know that they're one of the most flexible. They're there for a reason, because you cannot anticipate everything up front and all of the data can't be naturally represented. In Salve Regina's case, that ends up with an Excel processing step where, having moved data around, it now becomes necessary to deduplicate it, to clean it, and to derive inference and pull more facts out of the raw pieces of data that were coming out of the system. And that is finally then handed through to Tableau for a self-service reporting experience. Flow was designed upfront to know that this was how it was going to be in higher education. We knew that it wasn't going to be possible to just take a plug and connect it into a socket. We knew that we were going to handle problems like Ellucian or Moodle or Canvas or Blackboard expose us APIs, and there are calls we can make about those APIs. Okay, good. Sometimes the calls fail, you need a reliability layer where you will naturally try again a certain number of times before coming back to the user. Sometimes the calls have failed because your authentication token has failed out. Well, then you need to go and replace it, refresh it with another one. Sometimes you need to be able to say, the data that I'm getting from there, it would be perfect if I could just transform it right now for the downstream steps so that I didn't have to have an Excel workbench downstream. And for that reason, at many, many inflection points during a flow process, you will find a processing function which enables you to do arbitrary scripting against a payload and transform it into whatever you need it to be for the downstream layer. The manner in which we express this scripting is JavaScript. We have the most popular language in the world. It's dominant in Microsoft ecosystems, in Linux-based ecosystems, in web-based design, and in gaming platforms all over the world. If you throw a rock, you're going to hit 3 JavaScript programmers. Don't throw rocks at JavaScript programmers, folks. I didn't say that. We really needed to be able to support an institution in able to be using its very scant, very precious resources of staffing and not have people have to come in with elite specific programming skills. They needed not to have to know this particular obscure dialect or language or management structure. We needed the all-rounders who you've already got on your team, running everything from keeping the lights on to doing the business level reporting and anything in between. We needed them to be able to step into flow. And so we went with the scripting language, JavaScript, and we gave a lot of inflection points. What you are fundamentally manipulating then are configurations which are separately loaded so that your passwords and your credentials and your tokens are not sitting in the center of the programs to be shared and corrupted and tainted. And did you remember to upgrade every single one when we changed our password? But they're sitting in one auditable repository, securely housed. And there's only one copy of each password, and we know exactly who's got it, which means that we can separate out the scripting from the configuration. The scripting is then able to manipulate powerful under the surface primitives, such as Ellucian connectors, such as Canvas connectors, such as OAuth-based connectors or database connectors. All of the connector ecosystem that we bring is drawn from the Java ecosystem, an enormous dominant ecosystem that underlies a huge amount of the technology across the world and underlies flow as well. What this means in a higher educational context is that we don't come and say, there's an inbuilt connector for you to get students from colleague 16.1 on premise. We say we can deal with colleagues as a general class of system. We have specific authentication modules to colleague. We have specific reliability modules to colleague. And you can connect onto any of the APIs that you've seen in your colleague catalog. Moreover, we have a formidable array of work that we have done previously of recipes to connect onto systems. At this point, Flow has in its, as arrows in its quiver, some 220 distinct integrations across educational type systems in its ecosystem. The knowledge gained from those and the patterns demonstrated in those are available to flow partners as a sort of a playbook. They're not necessarily something that you would grab and just plug in, but they are something that you will adopt and adapt. We think that the right way to approach the flexibility required for a tertiary ecosystem is to present a pro forma use case and say, this is how it tends to be, and then to begin to tweak and refine for your particular use case. Chase, perhaps we'll move on slides. Now, we've talked a lot in a very general sense. To be specific, here are a set of things, not what we can do. I'm pretty comfortable in saying we can actually do very nearly anything with the flexibility that we've built in, but these are things that we do in production at partners where they are actually relying on us to be using it and getting it right. So if you are mentally checking off the boxes of, well, I've got that and this one's weird, and remember how we've got that system that vendors can never interact with us, I encourage you to have a look at this, not only as a list of things that we do, but also as a representation of the sort of capabilities and flexibility that we embody. Chase, is there another slide? And so the last slide was protocols, and the next one is systems, companies. We're integrated to these companies not only as a technical API consumer or as a database level account, we're also integrated to them at a corporate sense. So we are commercial partners with Blackboard, with Canvas, with Ellucian. We run our own instances of Moodle. We're a partner of TouchNet. And we have, where those sorts of partnerships aren't possible, we have friends on speed dial within the company, places that we've worked before, places that we've gone down into partners and we've solved problems together, and now we remember. I'm going to stop there, and I'm going to ask whether there are any questions in the room. Perhaps we'll look to the chat to see whether anything comes up.
You've both stumped everyone.
Maybe chat's broken. I mean, I want to assume that we've left them speechless at our erudition. But these are academics. They can talk and be talked at. Nobody ever made an academic speechless.
Okay, let's jump into a bit of a demo and actually dive into the platform.
What a good idea. Thank you, Matt.
All right, I've stopped sharing.
Can we all see that?
Yep.
All right. So this is an interesting one. We've talked a lot about what it means to play in this space. There are some elements of being a provider in this sort of space about reliability and auditability. When we move data from place to place, we are doing so with a student record. There are necessarily obligations of security, but there are also obligations of being able to explain what happened. Sometimes in a forensic sense, it's troubleshooting what's wrong with the data that we're getting from this place. Sometimes it's being able to furnish an explanation as an institution of what did we do with the data that we safeguarded. I'm going to run a flow right now, and what this flow is going to do is it's going to construct some data and it's going to run it against a campus system and is going to save in that data. The first thing that you'll see in the definition of this flow is that there's a huge amount of reporting capability. The work itself, as it is being performed, can be saved off to external databases for audit. It can be sent out to log consumers. It can be logged at particular levels. We have found this to be an enormously important part of interacting with this sort of ecosystem, where a frustrating amount of time as the IT department is spent seeking to explain what happened, even when there is not anything actually wrong. This is a flow program. It's written in pure JavaScript. And it says, I'm going to be a JSON request. I'm going to this path, and subsequently, I will be played against a particular consumer. The credentials for that consumer have been configured here. They are not represented inside this interface. If this call doesn't work, it should be tried 3 times at a maximum, and each of those retries must be at least 500 milliseconds apart. So let's actually run it. We immediately have feedback that we're running this particular one. It took 1.127 seconds. Let's see more. It ran these particular steps. No step executed it with any error. All right, but what was the nature of the first step that you ran? It was to make a particular call. This was the call. I patched a user with a GET request. No, sorry, I searched for a user. And this was what I got back. All of this data is available within Flow retrospectively for a user who wants to come in and go, well, what went backwards and forwards? What happened? So having got the user, we calculated a new state for the user, and we called back. This time, I'm right, it's a patch. We applied a military affiliation and a little bit of extra arbitrary data onto this user. And this time we got back the response. This is the state of your new user. And we have an overview structure here, where as an administrator, I can come in immediately and see what have we been running, what has been happening. There is an enormous amount of power to explore here. There is an entire CMS underneath resources. There is an entire network management layer around DNS overrides and reverse proxying and ensuring that you come from stable IPs so that things can be whitelisted. There is a test and simulation layer in connectors where you can take any existing connection that's been built between 2 systems in a production flow space, and you can come in and add arbitrary queries to try out against a system to give it an in situ smoke test. You can construct API structures. Those APIs may be listening on web points so that they can make immediate JSON responses or XML responses and perform activity downstream. You can construct those HTTP listeners so that they are simply going to reverse proxy through and pull data from and hand back to a user, having shielded the credentials, the access, and the precise mode. We use this a lot when it comes to partners coming to us and saying, we used to be able to rely on these physical facts of on-campusness, and what do we do now? What should we do now? We say, well, one of the options is to reverse proxy through to other systems. The message that I would like to takeaway from flow, the takeaway that I want to give is that you can configure it to do almost anything. You can configure it with skills and languages that you already have in-house. And then once you have done something, you are going to have extraordinary forensic insight into what took place and what happened. I know this looks like a complicated animal. It's a complicated problem. And as Chase said in the last slide, you don't have to do it alone. And I think that the rest of this conference and the partners who have been kind enough to come along and give their experiences and help us describe the way in which we hope to improve this domain, I think we will see as a whole how we approach the proposition of you don't have to do it alone.
All done, Chris?
Yes.
Okay. Based on anything we saw today, I just want to make sure that there aren't any questions. We've got 20 minutes or so to be answering anything. So if you like, throw something in the chat. Otherwise, you are always welcome to follow up with us and with the person you work with at your institution on the partner success side. Or I would encourage you to get in touch with Chris and I as well to have a conversation around flow.
Christine, let me thank you again for the wonderful work.
Not at all. My pleasure.
Well, thanks, everyone. And yes, echoing Chris's sentiments, Christine, thanks so much and for meeting with us beforehand to put all of this together. We know everyone's really busy at this time. So thanks again. And we'll be meeting with you soon to finish off a flow POC.
Mm-hmm.
Looking forward to it. Yes. I can't wait to get rid of some of those spider webs and get some point-to-point integrations going. It'll make our jobs easier here.
Hey, it's my friend Steve Carroll. Do you see who's in the chat?
I do. We got a comment.
It's Steve Carroll from Florida. Hey, buddy.
Okay. Thanks, everyone.